Hi there, welcome back to the channel. I am the Skandia V24. Welcome to the last video in the restoration series of me. And I'm doing this introduction because although I am the same age as the restorer, I'm a lot prettier. He's pretty ugly, isn't he? So enjoy the video and see me in my full glory. Have fun.
You know, sometimes you just have to keep things simple. And that's what I'm going to try to do here. I'm going to do or check the IF alignment on this, on the AM. See if we're off. We might not be. This thing was receiving quite well. But I want to show you, sometimes the instructions make us look at this in a rather more complicated manner than it deserves. What we're really trying to do is very, very simple. We are really just trying to ensure that all the circuits on the IF chain, and the IF on this guy is 460 kilohertz, all the circuits are as open as possible for the 460 kilohertz, the intermediate frequency which is carrying our signal. Now, the intermediate frequency is generated here in the mixer. This is the ECH81. So if you look at some of the instructions, they'll tell you to feed the signal directly to the grid. Some of them will tell you to feed it through a dummy load antenna to the grid. I always just feed it directly to the grid. And for that purpose, that's what I've got here. This little wire goes to pin 2 of the ECH81. The other side of the signal generator is connected to ground, just to the chassis. And the signal that's coming in here is 460 kilohertz with a modulated tone on it. In other words, I'm sending the IF frequency with a tone on it, and I'm going to try to listen to the tone and determine how strong that tone is at the output. And to make that pathway, the IF pathway, really well tuned, I need to get the best signal at the output, the highest amplitude signal at the output. That's all we're trying to do. And between this and the tube there that does, where is it? This guy here that does the detection, we have 4 filters. We have 2 IF transformers. Each one has got 2 cores that you adjust. And for the AM, it's actually these inner ones here. So it's this one here and the one below, which is reached on the underside. There's a hole in the board. This one here, and again the one below. And that's it. That really is all we're doing. We don't need to go into too much detail, and we don't even need to follow the order that they tell us to do. In the instructions, they tell us to do 4, 3, 2, 1. It doesn't really matter at this point, because what you do is you go back and forth anyway. You don't just do that one and that one and that one and that one and call it a day. Some of these things interact with each other. So you do it once, you peak it. You do it again, you peak it. So doing it backwards and forwards, you can do the 2 at the top first, 2 at the bottoms next, and you're going to redo that again. Ultimately, you get the right pathway, the right tuning. The pass band is improved every time you make a little small adjustment, and ultimately the result is to get the best pass band at the IF frequency through these 2 IF transformers. Those guys there, inside the same can, are for the FM. So let's look at, in detail, what we're doing, although we're going to keep this simple, right? So I told you the signal generator signal comes in here to the grid of the ECH81, but where does that come from? Well, it doesn't actually come from the signal generator straight away. It actually comes from this. This is my pi attenuator. It's a switched attenuator. It means I can attenuate the signal that's coming here, right, before it goes to the grid of the ECH81. Why do I do that? Well, my signal generator is really not an RF signal generator. It's not made for radio work, so the lowest amplitude that it produces is still too high for what the radio wants to see. So I've got this stepped attenuator here, switched attenuator, and I can add 3 dB, 6 dB, 12 dB, or 24 dB of attenuation. As we have it here, I've got 24 dB plus 6, so I've got 30 dB of attenuation of the signal that comes in here before it gets out there. There's also a capacitor between these two, so they're not directly connected. They are capacitively coupled, and this is good to avoid DC coming back into the signal generator. But then this signal comes from the signal generator, and here it is. It is at 460 kilohertz, the main frequency that I'm sending out. The amplitude I've got is as low as it'll go, and you can see that if I try to go lower, it won't allow me, and that's why I need the attenuation, because that's still too high. And my 460 kilohertz signal is being modulated. And if we look at the modulation that we have here, we've got AM modulation, 30% depth. I can make it more, but I normally use 30% depth, and a tone of 600 hertz. is what's being fed into that carrier so that I can then hear it. And I activate it, and that signal is now going to the grid of the CH81. And I'm going to be monitoring the audio at the output to determine whether my signal is at its strongest peak or not. And to do that, I've got this load here. This is the speaker output. It goes into here. This thing has got, this is a normal speaker that I got from a surround sound system, but I've added a dummy load in here so that I can either hear it as speaker or I can flick it, and I've got an 8 ohm load that replaces the speaker so that I don't have to listen to the noise, because then at the back I've got these guys. I'm monitoring the speaker inputs, and I'm taking this to a voltmeter, an AC millivolt meter. I've got a moving meter so that I can actually follow the peaking a lot easier than if it was digital. I've got it on about 0.3 volts, or actually it's on 0.3 volts. RMS full range. I can go up to 1 volt. It'll be low because I don't want very high volume on here. And I can then follow this and do the peaking. So it's as simple as that. So all we need to do now is to switch on the signal generator, switch on the radio, and see what we get. In the instructions, you see they tell you to put it on medium wave, which is what it is. They tell you to take it to 1650, so the top of the band. This is to make sure that the capacitor is fully meshed one way or the other. At the moment, they're telling us to go to the end. And if we now put the volume up, which is what they tell you to do, I've got the dummy load on speaker so I can hear it. There's my tone. I don't know whether that's peaked or not, but that's not the issue at the moment. The point is, I can hear my tone, and what I should do is make the amplitude of that signal coming in as small as possible, small enough that I can discern the tone, but not high enough to activate my AGC circuit. So with that 30 dB attenuation, this seems to be about right. They also tell you to put this volume on max. See why we have a dummy load on there? This can get really annoying. And we're ready to start adjusting the peaks. Simple as that. Keep an eye on the voltmeter and start tweaking that. But before that, I can now keep my eye open on the voltmeter. As you can see, it's reacting to that. Now, I can put it on max. I don't need to. Normally what I do is I'll put it about halfway because it gives me some range to play with the tweaking and see the results. And then I can adjust the amplitude or the volume to where I want it. If the tweaking takes it too high, let's say it takes it to there, then I can decrease the volume and I'll put it around the middle because it's nice and easy to control that way. And now we are ready to do the actual alignment. You see, setting it up and explaining it is a heck of a lot more complex than actually doing it. But it takes a bit of time to get this to become second nature. And sometimes, I mean, I don't even know how many radios I've restored. So I've really got to the point where I do this without thinking. And the reason I have to think is because I'm doing a video on it. Otherwise, I wouldn't even think about it. It would just be automatic. But I do sometimes try and remember what it was like before I did the first one. And it was very intimidating. I agree. I remember. I still remember. It was incredibly intimidating. And the easy part, or the easy part was actually doing it. But the difficult part was trying to understand why I was doing it. And once you understand why you're doing it on a particular radio of this nature, then the whole thing becomes simple and it becomes repetitive because just about every radio is the same concept, with a few little details, and the instructions normally give you the few little exceptions and details that would be pertinent to a particular set. But otherwise, it's common practice. It becomes second nature. So let's get cracking and do the peaking. If it needs it, we'll find out. All right, folks, let's get cracking. First one here. And I think these cores, I've got to find the right size screwdriver. This is a ceramic screwdriver. I think I've got it. Yes. There we go. See, that's pretty much unchanged. There's the peak. Now this one, as I thought, is pretty much peaked. Those two are done. Simple as that. Now let's turn this around and do the underside. Now you've got to get the right holes If you don't, you really mess this up. You can see here, this is the one transformer. There's one hole. That's the FM. That's the other one, AM. Here's the other one, FM, AM. So we'll go to, oh, this has got a bit of wax. The other one didn't. See if I can reach it. Trying to feel for the there's no change. I haven't got it yet. Of course, try not to touch anything that's going to shock you. That is not pleasant. I think I've got it. Got a bit more out of that. Not much. Not much at all. Where's the other one? This one's the other one. I can feel the top of it, but I don't know whether I've got the... Ah, there we go. I can't see any difference at all. I think those were peaked. And that really is it. Obviously, I'm going to redo it. You know, go back and forwards a few times, and every time you get a little bit more. But, I mean, that was pretty obvious, right? This thing was pretty much tuned, aligned. So I don't think we'll get much improvement. Not that it really needed it, but the IF alignment for the AM is effectively done just like that. Quite simple. No mystery involved. I'm just going to do a check of the RF alignment, see if that needs any adjustment. And the first thing they tell us to do is to make sure that the pointer is in the right position, which I've done. Obviously, if you're going to align the dial, you want to make sure that you're starting off from the right position and that pointer is movable on that dial cord over there. So they tell us to set it at 555 kilohertz. So we'll set the signal generator to 555 kilohertz. There's one little change I want to make here, and that is this thing, the signal from signal generator is going into the antenna socket at the back there because you're testing the RF. And so that means that you put a dummy antenna on here. Just to, you see I've got dummy antenna on here. I can bypass it or put it in. What this does is it makes this signal look like it's coming from a normal antenna. I don't know what the amplitude is going to be, so I'll leave it at minus 24 dB. This thing does have a cut as well, and we'll see if we pick it up when we get there. Otherwise, we'll just change the attenuation settings. So let's have a look at this over here. We're on the other end. Let's go to 555. Put the volume up. Signal's too low, so I'm going to... Far too low, actually. See if I take that off. See, it does attenuate it quite dramatically, but it's best to... I can hear it now. In fact, I'm going to give the amplitude here just a little bit of an oomph so that I can hear it better. And now we are at... That is exactly spot on. Exactly spot on. And if it wasn't, let's assume it wasn't, what would I need to do? Well, they tell us that for the 555, you have to adjust L44, and L44 is that guy over there. Okay, and also L21. Now, L21 is that guy there. It's that on the end of the ferrite. And this thing has been waxed in place, and I can see that nobody's moved it. So I'm not touching it either. So the next thing they tell us to do is to go to 1480. So I set this to 1480 kilohertz. Put the volume up. Tune to 1480, which is somewhere there. There's a little marker. Oh, geez. This is going to be boring. It's all aligned. I mean, look at this. There's the marker for 1480. This thing is 0.5 millimeter to the right. I suppose if I wanted to be strictly correct, it would be there. That's 1480. it's 0.5 millimeter to the right from the angle that I'm looking at it. So again, I'm not messing with that, but what would you mess with? Oscillator trimmer C41, and that is C41 down there. I suppose I could trim it just to show you. Let me put it exactly on. That's literally all I need to do. I'm going to loosen this with a metal screwdriver. You don't use metal, but to break the bond, sometimes there's a bit of a bond on this. There we go. If this, usually the actual screw is one terminal of the capacitor. And if they've done it right, they've made this the ground, so that if you touch it with a metal screwdriver, it doesn't actually change. And this is the case, look. But if not, what I do is I break the seal with the metal, and then I'll go in with the ceramic and make adjustments. But that's now perfect, perfect. And it was just a little tweak. And that's the oscillator corrected. And now what they tell us to do is C21 for the front end. Now where is C21? Oh, C21. CT21 is actually that little capacitor trimmer over there. And for that, you should use the meter because you're measuring for maximum amplitude. So again, we can look at the meter, change the volume. I'll put it on dummy and we'll see if we can get any improvement. I'm inclined to doubt it, but let me see. No change at all. So that's aligned. The RF is aligned for the medium wave. Simple as that. Now looking at the long wave, they tell us to set it to 210 kilohertz, which I've done on the signal generator, and we've come to 210, and again, look at this. It's bloody well on 210. I can't do anything to improve that. And I'm not going to mess with it. But if I did have to, I would have to adjust for the oscillator, the one below this on the underside. So that guy there, that can on the underside, I would adjust that for the oscillator. And then I would adjust this guy here for the antenna circuit, which, as I said, I'm not going to mess with. And then they tell us to do the shortwave. This is starting to get repetitive. 6.1 megahertz for shortwave. And that is falling precisely between the two little gaps that indicates where the pointer should be. So perfect alignment on there. Again, if I were to mess with it, it'll be L31, which is that guy there. So we messed with this one for the medium wave and short wave. That's the one for the medium wave and long wave. That's the one for the short wave. And also the antenna coil L11, which is one of these over here. I realized I've made a mistake with that trimmer capacitor, that antenna circuit trimmer capacitor for the medium wave. I messed with that one there. I corrected. I should have adjusted this one. That one there is actually for the short wave, as we will see. So let's go to the other end, which is 17.9 megahertz. And we adjust C11 if we need to. And C11 is the one that I thought was for the short wave over there. But let's go to 17.9 and see what happens. 17.9. Okay, let's go up here. Jeez. Again, just before, trying to see if there's those markers again. They don't have markers here for the 17.9. But it is, I mean, it's there. It's there. Okay, we're not going to do anything there either. So let me just show you what you would adjust if you had to mess with that one. Okay, the one you'd adjust would be that guy there. Now remember, I tried to adjust that for the medium wave. It was the wrong one. For the medium wave, I should have adjusted that one, which I've now corrected. But again, that there, no difference. I won't even bother with it. So it looks like that's also pretty much in alignment. And that is pretty much all the alignments that we need to do for the AM bands. And as you can see, there was very, very little to adjust. You could live with those slight deviations that I try to correct here on medium wave for basically just to show you. But you don't need to. I mean, none of the stations that we get nowadays are actually at precise frequencies. So the absolute perfect alignment on the band is really academic. Mind you, academic is sometimes fun, so you've got to do it for the sake of learning. But after a while, you start understanding what counts and what doesn't. And none of the changes, none of the adjustments I did on this radio today were necessary. The radio was, according to the results we got from the alignment, in pretty good alignment. Now, should we do it? Well, yeah. I mean, that's what we do here. We're restoring a radio, so part of the fun is messing with these things. Otherwise, all you're doing is cleaning. But you don't need to. If this is the first time you're getting into one of these, there are a lot of videos in the past on my channel and other channels where we go into a lot of detail as to how to do this. And it's important if your reception is bad. It's important if someone has messed with these cores, because they usually do. If people have access to screws, to cores, they will put a screwdriver in there. And the worst thing that can happen is they can break the core, which is a bloody nightmare. But on this particular set, as you've seen, it wasn't necessary. It was pretty much good enough. And that's pretty much it. That was the IF alignment for the AM, and then the RF alignment for medium wave, short wave, and long wave. Just an additional comment on these ferrite antennas. The reason I don't like messing with them is that these things you can't really mess, you can't adjust them with your fingers. The adjustments on these coils is really where you put it on the length of the ferrite. So you actually shift it up or down the ferrite rod. That's the long wave, that's the medium wave. But that's all you do. And if you do that with your fingers, it affects the reception. So you got to do it with an insulated stick or something. And it's very, very difficult to get it to the exact spot. And if there's wax on there, if you can see the wax is original, then nobody's messed with it. If nobody's messed with it, you'll find no matter how many times you try to adjust it, it won't get better. It sometimes gets worse. But I've found on very, very few occasions these things have been messed with. So if they're not, I try to leave them alone. And that's about all I've got to say about the alignment for the AM. And this is what I got to say about the alignment for the FM. I did absolutely nothing to it. I did try to tweak a little here and there on the IF. I wasn't getting any improvement, so I left it as is. And this thing is working very, very well.
Hoje será que tivemos uma coisa dessa? Com o alarme social que houve a propósito da intempérie? Ou foi justificado?
There is something intermittent on here. This thing is maxing out, and it wasn't doing that for a while. I don't know if you remember when I was doing the FM, it was maxing out, and then for some reason when I cleaned that the components, it went back to normal, but it's still maxing out. It's working. Just seems that the signal's a little bit too strong over there. I might sort of have to open it up and see what's going on there. But this thing's working. As you can tell, there's football going on. This goes to 104, but I've got nothing up here. But I guess it's a good time to see how the other bands are behaving. Let's try them out. I'll just change the antenna for the mini whip at the back, and we'll try the AM bands. Let's try the medium wave.
La mortalidad infantil se ha reducido a la mitad y la de las mujeres en el parto en un tercio. En los últimos años se han desarrollado contra la malaria y el ébola, y la OPUS ha sido la organización de la crisis.
Semana Santa en COPE.
También en cope.es.
Cuando tienes hijos pequeños es lógico. Tomar algo y otras tardes hay formación.
Well, as usual, all the Canary Island stations coming through like they were just next door. Instead, they're 400 kilometers away. The local band, local station over here, pretty good. Remember, this is with my mini whip. If I didn't have the mini whip, it would be a different story. Let's try a long wave. It's a little bit early, but...
Il y a deux types de carburant, le carburant ordinaire et le carburant supérieur.
As usual, long wave, short wave.
Что о ней сохранилось множество писем.
La loro comparsa in Francia una situazione di equilibrio.
This is the 31 meter band over here.
Со времени династии
Got a bit of a storm going outside, so surprised we're still getting something up here at this time of the day.
Lo que toca ahora en los últimos años es volcar el sistema.
And there we have it. That, my friends, is our little Skandia. Looking really, really nice. This thing came out absolutely beautifully. No dings, no faults. The only little repair or touch-up I'm going to have to do is on that magic eye. I've got to figure out what's going on there, but that'll be easy enough. This thing is very, very simple to remove. I'll just take the mini whip out here, and she can do the full spin. Look at this. Obviously, this goes in to give it FM reception. The back is in perfect condition as well. There was that little stain down here, which you are hard-pressed to notice. I mean, if I point it out, you can, but otherwise, it's practically invisible. And thus, I arrive at the end of another project. And I must say, doing the cabinet before really took a weight off. I've told you before, I don't particularly like cabinet work. I know how to do it. Dave Tipton is the master, and he's not in Madeira. He's a little bit far away. Anyway, I want to thank you all for your company on this project. I really enjoyed it. It's really special, the fact that it's from the same year that when I was born. It gives it a little bit of a little special flavor, a little special motivation to do a good job. You'd hope that if someone was restoring you, they would pay the same sort of attention. I know it's stupid, but sometimes I am that way. So once again, I want to thank you for your company. I hope you've enjoyed this series. And if you have, click like, share, subscribe, and all that jazz. And don't forget, if you want to support the channel directly, you can do so on Patreon and PayPal. I've got the links in the description below. Thanks for watching. Bye for now, and stay safe.